And then today I'm going to be doing my first chemistry video, which is going to be on Unit 5, the mole, and some calculations about it. Now, the mole of a substance is the amount that contains the same number of units as the number of carbon atoms in 12 grams of carbon-12. 1 mole of any substance contains 602 that many atoms, or 6.02 times 10 to the power 23 atoms. Now, this is called the Avogadro's constant, worked out by the scientist Avogadro from Italy in 1811. Now, 1 mole of any substance is obtained by weighing out the AR or the MR of the substance in grams. Now, AR stands for atomic mass, MR stands for molecular mass. Now, how exactly do we work out an AR or MR of a substance? Let's take lithium right here. Now, in order to do that, we need to take its atomic weight or mass. It is right here, this number. So it is this number right here. Now, this wasn't very clear, but you can actually see that the atomic mass of lithium is 4 point something. So that's roughly 4. So that means 1 mole of lithium atoms contains this many lithium atoms and weighs 4 grams. Okay? Now, let's take oxygen. Now, oxygen on its own, for example, let's take an oxygen atom, is 16 grams right here. But oxygen normally exists as O2, or oxygen gas. Now, that, we need to take its MR, or its molecular mass, because it's a molecule together. So that means you need to times 16 by 2, which is equals to 32 grams. Alright. Now, here are the first calculation of the mole, which is calculating the mass. Now, the mass of a given number of moles equals the mass of 1 mole times number of moles. That's pretty straightforward. Now, the number of moles in a given mass equals the mass divided by mass of 1 mole. So this is basically here is the calculation triangle right here. You can see that the mass in grams of a substance that you wanted to find equals to the mass of 1 mole of that substance times the number of moles there is. Now, you just cover the one that you want to find, and then you'll know how to calculate it. Now let's do some questions regarding that. Now, this is a question. Calculate the mass of 0.5 moles of bromine atoms. Now, the AR of bromine is 80. 1 mole of bromine atoms has a mass of 80 grams because it's a bromine atom, so basically it's 1 of them. So 0.5 moles of bromine atoms has a mass of 0.5 times 80, which is mass of 1 mole, which you can relate to the calculation triangle right here, equals to 0.5 times 80 grams, or is 40 grams. That's pretty straightforward question. Now the second one is, how many moles of oxygen molecules are in 64 grams of oxygen? Now, the MR of oxygen is 32, as stated before, so 32 grams is 1 mole of oxygen molecules. Therefore, 62 grams contains 64 divided by 32, or 2 moles. That's also pretty straightforward. Now, here are some practical calculations. Now, there are 5 little questions to this question, but we are only going to do A, B, C for now, because we have only done how to calculate masses. We haven't done how to calculate concentration yet. Now, the question is, 27 grams of aluminium burns in chlorine to form 133.5 grams of aluminium chloride. Now, the AR for the 2 elements are given for you. Aluminium has a mass of 27 grams per mole, and the chlorine has a mass of 35.5 grams per mole. Now, question A. What mass of chlorine is present in 133.5 grams of aluminium chloride? Now, this question is actually pretty straightforward. You'll know that 6.27 grams of aluminium is present in 133.5 grams to. Now, to find the mass of chlorine, you simply just have to minus 6.27 from 133.5. Now, why is that? Because the total mass of all the reactants and products inside the chemical reactions does not change. For example, if you have 40 grams of reactants, in the end, you should get 40 grams of products. That's set. You cannot, for example, get 20 grams of reactants and get 10 grams of products. That's not possible unless you are living in some planet else. Now, first question is done. Now, how many moles of chlorine atoms is this? Now, to find the mole, you need to use the mass to divide by the mass of 1 mole. So, the mass here is 133.5 minus 6.27. You get that mass, and then you divide it by 35.5, and you get how many moles of chlorine atoms is that. Now, how many moles of aluminium atoms are there present in 27 grams of aluminium? Now, the atomic mass of aluminium is 27, and there's 27 grams of aluminium, so you use 27 divided by 27, which is 1 mole of which means there's 1 mole of aluminium. Now, here's basically the thing that I tell you out. An equation tells the number of moles each factor has, and the mass is in grams of them. So basically what this means that you can get the number of moles present in each of the reactants and the products, as well as by calculating their MR, find you that what is the mass of 1 mole of that reactant or product you have. Then the total mass does not change during a chemical reaction, and depending on the question, you might be asked to calculate masses from equations or working out equations from given masses. Now, here is basically the working of the previous question. Aluminium, 27 grams, total mass. Alright, I just made a mistake there. This is 27 grams of aluminium. This is 6, this is the question number, sorry. So basically, aluminium, you have 27 grams. The total mass of the product is 133.5 grams. So the mass of chlorine must be 133.5 minus 27 equals to 106.5 grams of chlorine. Now, second one, how many moles of chlorine is that? Number of moles equals to mass divided by MR, or molecular mass, so it's 106.5 divided by 33.5 equals to 3 moles. That's 3 moles of chlorine. The second one is pretty very straightforward. I'll just explain to you, and then that's it. Now I'm going to talk about reaction in gases. Now, 1 mole of every gas occupies the same volume. At the same temperature and pressure, and at room temperature and pressure, this volume is 24 dm cubed. Now, the molar volume of a gas is 24 dm cubed at RTP. That means 1 molar of a gas is 24 dm cubed at room temperature and pressure. Now, here are the two equations. Volume at RTP in dm cubed equals to the number of moles times 24 dm cubed. Now, 24 dm cubed equals to 24 liters equals to 24,000 centimeter cubed, roughly the volume of a ball, 36 centimeter in diameter. Okay. Now, here are some questions, because this topic is a heavy calculation based topic, because we have to calculate a lot of things. That's it. Now, example 1. What volume does 0.25 moles of a gas occupy at RTP? Now, 1 mole occupies 24 dm cubed, so 0.25 mole, which is 1/4 of 1 mole, which means is 0.25 times 24 dm cubed equals to 6 dm cubed of gas. Now, example 2. Now, what volume does 22 grams of carbon dioxide occupy at RTP? Now, the MR of CO2 is 44. So 44 grams is 1 mole. 22 grams is 44 grams divided by 2, so it's 0.5 moles. So the volume occupied by 22 grams of carbon dioxide is 0.5 times 24 dm cubed equals to 12 dm cubed. Now, you might be asked to find gas volumes from equations. Now, here's example 1. What volume of hydrogen will react with 24 dm cubed of oxygen to form water? Now, the equation for the reaction, this is the wrong word there, is 2H2 plus O2 goes to, I can't type the arrow, so I have to use go to, 2H2O. Now, here is what I meant by you can get, as from the previous slides. Here we go. Where is it? The number of moles each factor has and the mass in grams of them. So basically here is the explanation. Now, here you get the equation. Now, the big number in the front, so basically this is 2. I can't make the 2 smaller, so you have to know that this 2 is H2 small 2. Now, the number in front, right here, tells you the number of moles. So this is 2H2, which means there's 2 moles of hydrogen. If you see no number in the front, that means there's only 1 mole. And here, then 2 tells you there's 2 moles of water. Now, what does it mean by the mass? Now, the mass is basically, you find whatever the AR of the reactant is, and whatever the AR or MR of the product is. So basically, this is hydrogen. The molecular mass of hydrogen is H2, and one hydrogen atom is 1 gram, so H2 is 2 grams. And respectively, you can find the mass of oxygen and water. And here's the calculation. So 2 volumes of hydrogen, which basically is 2 moles of hydrogen, react with 1 mole of oxygen. Or 2 times 24 dm cubed, which is 2 moles, react with 24 dm cubed of oxygen. So basically it is 43 dm cubed of hydrogen will react. That's pretty simple. Now, example 2. When sulfur burns in air, it forms sulfur dioxide. What volume of this gas is produced when 1 gram of sulfur burns? Now, the equation is S plus O2 goes to SO2. Now, this is pretty straightforward. 1 mole of sulfur reacts with 1 mole of oxygen gives you 1 mole of sulfur dioxide. That's basically the simplest ratio you can get. Now, 32 grams is 1 mole of sulfur. So 1 gram of sulfur is 1 over 32 mole, or 0.032125 mole. Now, 1 mole of sulfur gives 1 mole of carbon sulfur dioxide, because it's 1 to 1 to 1. So basically, well, you get it from the equation. So in here, you have to think of this number here to be 1, because it is 1 gram here. So this is 1 mole. So 1 mole gives 1 mole. So basically, it means 0.03125 mole of sulfur gives 0.03125 mole of sulfur dioxide. That's the same as well. So where is my calculations? It's not this one. Here we go. So basically, here, what volume of this gas? So basically, next you use the equation of gases right here. Volume equals the number of moles times 24 dm cubed. So basically, you use this number times by 24. You get the number. You get the volume. You get the volume of the gas as well. Now, here's another question. Nitrogen monoxide reacts with oxygen like this. 2NO plus O2 goes to 2NO2. Now, here's question B. What volume of oxygen will react with 50 centimeter cubed of nitrogen monoxide? Now, here's my working. So the volume equals the number of moles times 24 dm cubed. So basically, firstly, you have to change the 50 centimeter cubed into dm cubed. So basically, 50 divided by 1,000 equals to 0.05 dm cubed. Now, so basically, we know that 1 mole of any gas at RTP is 24 dm cubed. So this is 0.05 dm cubed. So how many moles of gas is that? You have to use 0.05 divided by 24, gives you 1 over 480 mole. Now, we know from the reaction that 2 moles of nitrogen monoxide react with 1 mole of oxygen, goes to 2 moles of nitrogen dioxide. Now, so basically, there's 2 to 1 to 2. So 50 centimeter cubed of NO is that many moles. So they ask you what's the volume of oxygen. Firstly, you have to find what mole of oxygen is in this equation for the given volume of the nitrogen. So basically, 50 centimeter cubed, or 1 over 480 mole, is equals to 2 mole, because there's a 2 right here. So basically, you use 1 over 480 divided by 2 gives you 1960 mole, which is the actual number of moles in the oxygen with the given volume of nitrogen. And then you use this to times 24 dm cubed to give you the volume, which equals to 0.025 dm cubed, which, if you want to change it into a whole number, you times about 1,000, it gives you 25 centimeter cubed. So there's your answer. So basically, to answer these type of questions, you have to know what equation you have to use. Now, you may be using more than one equation in one question. You may be using the gas equation first and then the mass equation, or the other way around. So basically, firstly, you use the gas equation, then you use the mass equation, then you change it back to the gas equation. Pretty straightforward, this question. If you just understand which number is which, and then you'll know. Now we came on to the last part of this video. Is about the concentration of solutions. Now, the concentration of a solution is the amount of solute, a salt, in grams, there's an m missing there, or moles, that is dissolved in 1 dm cubed of solution. Now, the concentration, the unit is given in mole per dm cubed, equals to the amount of solute in moles divided by the volume of solution dm cubed. And the amount of solute in moles equals to the concentration mole per dm cubed times volume dm cubed. Now, here's a practical question. We're gonna fall straight into this because it's pretty easy to explain this way. Now, here's a question. You have to prepare some 2 molar solution. So basically, the concentration in this question is set. So for each of the solution you have to prepare, the concentration is 2 moles per dm cubed. With 10 grams of solute in each, what volume of solution will you prepare for each solute below? Now, the AR is given to you. H equals to 1, hydrogen equals to 1, lithium equals to 7, nitrogen equals to 14, oxygen equals to 16, magnesium equals to 24, and sulfur equals to 32. Now, the first solution you have to prepare is a solution of lithium sulfate. Now, the formula for lithium sulfate is Li2SO4. Now, this is how you do it. Firstly, you have to write down which formula you have to use. Now, for this question, you have to use the volume equals the mass of solute divided by concentration. Now, the MR of lithium sulfate is 110. You just use the MR there, and how many atoms are there, you just multiply it out. So basically, it's Li 7 times 2, there's 2 of them here, plus 32, plus 16 times 4, gives you 110. So 1 mole of lithium sulfate equals to 110 grams. Now, there's 10 grams of this lithium sulfate, so it is 10 divided by 110, gives you 1 over 11 moles of lithium sulfate. Now, you will have to divide that by 2 because, using the other equation, the amount of solute equals to the concentration. You have to divide by 2. It gives you 1 over 22 dm cubed, and you times that by 1,000. Times that by 1,000 gives you 45.5 centimeter cubed. Now, the reason you have to divide 2 over there is because the volume equals to the mass of solute divided by the concentration. Now, the mass of solute, you already know that, is 1 over 11 mole. That's the mass. The concentration is set, which is 2 molar. You take it as 2. So it is 1 over 11 right here, divided by 2, gives you 1 over 22, which is the volume of the solution you have to prepare. Now, this is in dm cubed, which is going to give you a decimal, so it is best to change it into a whole number, times it by 1,000 to change it into centimeter cubed. Now, this is the volume of the solution you have to prepare for 10 grams of lithium sulfate. Now, question B is magnesium sulfate. Now, same process, same equation right here. MR of magnesium sulfate is 120 grams. Use 10 to divide by that, gives you the mole. Divided by 2, the concentration gives you the volume. Change it into a whole number, and then that's basically it. Now, the third question is basically the same, different salt. MR of this is ammonium nitrate, which is NH4NO3, is 80 grams. 10 divided by 80 is 1 over 8 mole. 1/8 divided by 2 is 1 over 16 dm cubed, the volume, and then you change it into centimeter cube. These 3 questions follow the same process, and then once you've done the first one, you know how to do the second one and the third one, basically. Now, I'm going to end the video here, because, and I'm going to do a second part tomorrow, which is going to be on finding the empirical formula, as well as finding the empirical formula, finding the final formula, as well as calculating the percentage yield and purity. Now, this topic is very, very confusing because you have a lot of formulas to memorize, and then the formula can change. But once you memorize all the formulas and then you identify the questions, basically, when you come to a question dealing with moles, firstly, you have to find out, what is this question about? Is this question asking you to find the mass, the concentration, the volume of a gas, the empirical formula, or the final formula, or the percentage yield or purity? Now, once you identify that, you have to, basically, if you don't remember the formula that well, you can write them down. Write them down on the page first, and then from the equation or the mass given, identify which value given is which, and then you apply these to the formula, and then you'll get it. Now, I'll see you in the next video. Goodbye.